Hi everyone, let's see another type of shift register, and this is very famous. Many gate questions they are basically based on this linear feedback shift register, and this is a very simple shift register. Okay, the you don't have to basically this name. Okay, this name doesn't matter. Okay, you don't have to worry about this name. You don't have to remember this name. Okay, so don't worry about this name. But let's analyze this register. So this shift register on your screen, let's analyze this. Okay, so first of all, what is this linear feedback shift register? Okay, what this means, it is very simple register. This is a shift register, but in this shift register what we do, okay, some of these outputs, okay, for example, okay, so you can notice these okay, this is a flip flop, this flip flop output, this flip flop. So you have total 4 flip flop. Okay, so you have total 4 flip flop output. Okay, some of these outputs basically they we combine them using an exclusive OR gate. Okay, so this type of register we call it LFSR. Okay, so this is linear feedback shift register. Remember, the name does not matter. You don't have to remember the name. Okay, but you have to analyze the circuit. If this circuit is given in the gate exam, then you have to analyze this circuit. Okay, I am just telling you that this linear feedback shift register, what is this? This is a shift register. This is a serial in serial out shift register. Okay, so this is basically a serial in serial out write shift register where the serial input is generated. So you can notice there is no external input here. There is no external input. You can notice there is no external input here. So here the serial input is generated as a linear combination, or I can say using exclusive OR of some of the flip-flop outputs. Okay, you don't have to take this and this. Okay, remember, this is just one example. Okay, for example, you can do this also. Okay, either you can do this, or what you can do, you can do this type of thing also you can do. So let us assume that these are your registers, and what you can do, so remember I told you that this linear feedback shift register, this is a shift serial in serial output. This is a serial in serial output register. Okay, right shift register. But what is the point? The point is that there is no external input here. There is no external input here. Actually, the serial in here, okay, the serial in, this is a exclusive OR of some of the outputs. For example, what I can do, I can take this, okay, and I can take maybe this, and I can put their, okay, exclusive OR. I can put their exclusive OR. Okay, and then I can connect here. Okay, so this is also your LFSR, linear feedback shift register. Okay, so this is also linear feedback shift register. So I hope this point is clear to everyone. Okay, so so this is the point. Okay, you can basically something like this. What I can do, okay, so something like this. Okay, so now you can notice this is also linear feedback shift register. Okay, so anyway, the idea is very simple, that in these type of registers you can notice there is no external input. We don't have any external input. Actually, the serial input is basically the combination of the linear combination. Okay, I can say the serial input is basically exclusive OR of some of the outputs. Okay, so this is the out. Okay, I can say the serial input is generated as a linear combination, or I can say exclusive OR of some of the flip-flop output. For example, this circuit you can notice, okay, in this circuit you can notice that the serial input, okay, that is basically exclusive OR of Q1 comma Q4. Okay, so this is your linear feedback shift register. Now, why this is important, let's see. Okay, so first let's see. Okay, let us assume that you have 0 0 0 0. Okay, let us assume that initially you have 0 0 0 0. Then what will happen? Okay, so let us analyze this. If initially you have 0 0 0 0, then what will happen? Tell me. Okay, so you can notice initially if you have, so let's assume Q1, Q2, Q3, Q4. Let us assume initially you have 0 0 0 0. Okay, so at time t equal to 0, this is your situation. Then at time t equal to 1, what will happen? Okay, so you can notice all these, let us assume all these are 0 0 0 0. Okay, then in the next clock pulse, what will happen? After one clock pulse, I can say, because you can notice all these flip-flop here, you can notice these are positive edge triggered. So I can say after one positive edge, what will happen? So okay, after one positive edge, what is going to happen? This is going to happen that, okay, after one positive edge, what will happen? So you can notice 0 0 0 exclusive or 0, that is 0. Okay, so after one clock edge, this is going to happen that this will be 0, because you can notice, okay, you can notice one thing, that D1 is basically Q1 exclusive or Q4. Okay, so you can notice what is this D1. This D1 is basically Q1 exclusive or Q4. So you can notice after one clock pulse, what will happen? This Q1 exclusive or Q4, that is 0. Okay, so because D1 is equal to Q1 exclusive or Q4, and you can notice D2 is simply Q1, and you can notice D3 is simply Q2, and you can notice D4 is simply Q3. Okay, so I can say that after one clock pulse, after one positive is what will happen? 0 exclusive or 0, that is 0. Okay, and then what will happen? Very simple. This 0 will go here, this 0 will go here, this 0 will go here. Now you can notice that if you initialize this circuit, okay, in this circuit you can notice if you initialize with 0 0 0 0, if the initialization is done, and if this is your initial state, I can say that if this is your state 0 0 0 0, if this is your state, then you will all again go to this state. You will never get out of this state. So you can notice in this circuit, if you initialize 0 0 0 0, if you initialize like this, then the next state will also be 0 0 0 0, the next state will also will be 0 0 0 0. Okay, so you can notice. Anyway, so we should not do this. Okay, we should not initialize using all zeros. So what we can do, let me initialize using 1 0 1 let me initialize like this. Okay, so let me do the initialization like this. So basically don't initialize. Okay, so here I can say if you initialize at 0 0 0 0, then you will basically, okay, this state you will never change this state. Okay, so basically, so okay, don't initialize. So I can say don't initialize uh, as 0 0 0 0. Okay, don't initialize as 0 0 0. Why? What is the reason? The reason is very simple, that if you initialize by 0 0 0 0, the next state will be 0 0 0 0, and the next state will be 0 0 0 0, and so on. Okay, so that is the reason there is no use. Okay, if this type of situation is not useful to us. Okay, so now let me assume that, let me initialize like this. Okay, let me initialize, let 1 0 0 0. Okay, let me initialize like this. Now what will happen? So now you can notice that this is your Q1, Q2, Q3, Q4. What I have done, so you can notice at time t equal to 0, this is the initialization. I have initialized like this. Okay, 1 0 0 0. Okay, you already know that D1 is equal to Q1 exclusive or Q4. Okay, you also know D2 is equal to Q1. You also know D3 is equal to Q2, and you can notice D4 is equal to Q3. Okay, so at time t equal to 0, this is the initialization. After one clock pulse, what will happen? So you can notice, because you can notice that all the flip flop, these are positive edge triggered. So I can say after one positive edge, what will happen? So this exclusive or this one exclusive or 0, that is 1. Okay, so this will become 1, and you can notice this will become, this 1 will go here, this 0 will go here, this 0 will go here. Okay, so because you can notice why this is happening, because you can notice D2 is equal to Q1. Okay, so this D2 is equal to Q1. Okay, and Q2 is equal to D2. You already know in a D flip flop, I can say that Q2 is equal to D2. In a D flip flop, in any D flip flop, what I can say, in a D flip flop, you already know that in a D flip flop, what happens? I can say that Q next is equal to D. Okay, so you can notice this will happen. So I can say that after at time t equal to 0, this is the initialization, and after one clock pulse, what will happen? One exclusive or 0, that is 1. So this will be 1, and okay, and this one will be shifted here, and so on. Okay, after next clock pulse, what will happen? After one more positive edge, what will happen? Again, this one exclusive or 0, that will become 1. Okay, and this will, 1 will go here, this one will go here, and this 0 will be stored here. Okay, after one more clock pulse, after one more positive edge, what will happen? After one more clock pulse, what will happen? This 1 and this 0 exclusive or, that is 1. Okay, and this one will go here, this one will go here, this one will go here. After one more clock pulse, what will happen? This one exclusive or 1, that is 0. Okay, and this one will go here, this one will go here, and this one will go here. Next, what will happen? T5. Okay, again after one more clock pulse, what will happen? This 0 and this 1, that will become 1. This 0 will go here, this one will go here, this one will go here. Okay, now similarly you can just keep doing. Okay, like this you just keep going. Then what will happen in the next? Okay, what will happen? So this one that will become 0. Okay, so this will become 0. This one will go here, this 0 will go here, and this one will go here. So this will be 0 1 0 1. Okay, After next clock pulse, what will happen? I can say that T7. Okay, so I can say what will happen at T7, Q1, Q2, Q3, Q4. So at T7, what will happen? So this 0, this 1, okay, exclusive OR of 0 comma 1, that will become 1, and then this 0 will go here, and then okay, this 1 0. Okay, so this will happen. Now at time t equal to 8, okay, so again this exclusive OR this, so that will become 1, and then this will become 1, this will become 0, and this will become 1, and then at time t equal to 9, this and this exclusive OR that will become 0, this will become 1, this will become 1, this will become 0. Okay, at time t equal to 10, what will happen? Okay, so this exclusive OR, so this will become 0, this will become 0, this will become 1, and then this will become 1. Okay, so at time t equal to 11, what will happen? So that will, okay, what will happen here? So here this will become 1 0 0, and then it will become 1, and finally time, okay, here you can notice the same pattern will come, okay, from where we started. That no, wait, maybe some mistake we have done. So there is no mistake actually. Okay, so okay, now in the next clock pulse, what will happen? So this one and this one, so that will become 0, and this will become 1, and okay, so this will go 0, and then this will go 0. So this you will get, okay, 0 1 0 0. So have we gotten this state 0 1 0 0 anywhere? 0 1 0 0, we did not get it. Okay, so anyway, so in the next clock pulse, what will happen? So you can notice T13. Okay, this is your Q1 Q2 Q3 Q4. Okay, so in T13, what will happen? So this 0 exclusive or 0, so that will be 0, and then you have 0 1 0, so then 0 1 0, and then in T14, okay, you will get 0, and then 0 0 1. Okay, so from where we started, okay, have you gotten this? T15 will be 1 0 0 0. From this is your initial, okay, this is your initial from where you started. Okay, so we started from here and we got here. Okay, so this is what we started. So you can notice, okay, so from where we started, so this is your, I can say this is your initial, this is your initial combination. Okay, so I can say this is your initial combination. So okay, very simple point what I want to say is that in the gate exam they will give you some circuit. Okay, so for example, they can give you this register, and they will say that okay, this is the initialization. They will do the initialization. For example, here what I have done, I have done the initialization like this. Okay, this is the initialization I have done. Now what will happen? After every clock pulse, okay, you can notice the content will change. Okay, after every clock pulse, the register content will change, and the register content will change like this. You can notice this is the initial. Okay, after one clock pulse, this T1 means after one clock pulse, T2 means after two clock pulse, and so I can say that after 15 clock pulse, you will again get the same data. Okay, so here you can notice, okay, so after 15 clock pulse, so after 15 clock pulse, after 15 clock pulse, we get same initial same initial data, and this is our initial data. So this is our initial data. So after 15 clock pulse, again we get the same initial data. It's like this. Okay, initially this is the state. Okay, so you can make a state diagram. State diagram you can make. Remember, let me tell you that when we talk about flip flop, okay, when you talk about flip flop, then remember that the output of the flip flop is called the state. Okay, so when you talk about flip flop, then basically state simply means output. Okay, so for example, if you have a flip flop, let us assume this is your D flip flop and the output is 1. Okay, this is your, okay, then we will say that state is 1. Okay, here I can say the state is 1. Similarly, let us assume that you have multiple flip flop. Let us assume that you have, let's assume you have 3 flip flop. Okay, and let's assume here the output is this type of situation. You have 0 1 1. Okay, now you can notice here the output is 0, here the output is 1, and the output of this last flip flop is 1. Okay, so for this whole circuit, for this sequential circuit, this is your sequential circuit. For this sequential circuit, what is the state? I can say for this sequential circuit, state is 0 1 1. Okay, so this is the state 0 1 1. So remember, state basically means output. Okay, so here again you can notice that in this example, okay, this is our initial state. So our initial state is 1 0 0 0. Okay, okay, in, so from here where will you go? From here we will go to okay, you can notice this exclusive or this, so that will become 1, okay, because remember this exclusive or this, that will become 1, okay, and then you will have 1, okay, then you have this, okay. So remember it's like this. Let me tell you what is happening here. So in our, I can say, in this, in the previous register, in the previous register, in the previous register, basically in this register, okay, we are talking about this register, we are only talking about this register. In this register what is happening, let me tell you, in this previous register what is happening. So if you are in this state, if you are in this state a b c d, then from here where will you go? You will go to, you will go to this exclusive or this, so you will go to a exclusive or d, okay, and then a b c, okay. So if you are in this state, then you will go to this state, correct, okay. So you can very easily, example, you can check 0 0 0 from this state, you will basically go to this state, okay. Similarly you can notice from this state 1 0 0 0, from here what you will do, you will go to 1, or then 1 0 0, okay. From here where will you go? You will go to 1 and then 1 1 0, okay. From here where will you go? Again 1 and then 1 1 1, okay. Again from here where will you go? You will go to 0 1 1 1, okay. Again from where will you go? You will go to 1 0 1 1, okay. From this state where will you go? From this state you will go to 0 1 0 1, okay. From this state where will you go? You will go to, okay, 1 0 1 0, okay. Now from this state where will you go? From this state you will go to 1 1 0 1, okay. And from this state where will you go? You will go to 0 1 1 0, and from this state where will you go? You will go to 0 0 1 1, and then from this state where will you go? You will go to 1 0 0 1, okay. And from this state where will you go? You will go to 0 0 sorry, 0 1 0 0 0 1 0 0, okay. And so on. From here where will you go? You will go to 0 0 1 0, and so on, basically like this, okay. And so on. So you can notice after 15 clock pulse, okay. So after 1 2 3 4 5 6 7 8 9 10 11 12 13, actually after 15 clock pulse you will actually go to here, okay. So here actually I don't have a space, so let me write it. From here where will you go? Okay, so from here you will go to 0 0 0 1, and then from here you will go to here, okay. So you can notice after 15 clock pulse again you are coming back to the same state, okay. So anyway, this is the this is how you can analyze this register, okay. Now why this register is special, let me tell you, okay. What is the reason that this register is special? So why this register, why this linear feedback shift register we study, okay. So the application of this linear feedback shift register, what is the application of linear feedback shift register, okay. What is the application, why we study this? So let me tell you, the application is basically, this is your pseudo random generator, okay. So actually the I can say application is basically, that is random generate the random number generation, random number generation. If you want to generate random number, then you can use this linear feedback shift register, okay. So the application is random number generation, okay. Okay, how random number is generated, let me tell you. So you can notice that you started in this state, in this state you started. So this state is your 8, I can say, okay. This is your 8 1 0 0 0, so that is your 8. So you can notice that you started in this state, and what is the next state? This 1 triple 0, that is 8, okay. And the next state you can notice that is 12, and the next state, what is that? The next state is, you can notice, okay, 1 1 1 0, okay. So the next state is basically 14, and you can notice what is the next state? The next state is 15, okay. And the next state, what is that? That is 7. So okay, that is 7. And what is the next state? So you can notice the next state is 1 0 1 1, that is 11. So can you notice like this, and so on, okay. So you can notice this is a random sequence, okay. So random number, or I can say random sequence generator, random sequence generator, okay. So using this linear feedback shift register, you can generate this random sequence. You can notice, okay, we started from this number 8, then you can, okay, you can generate 12, then 14, 15, then 7, then 11. So basically randomly we are generating this sequence. Okay, so this is the application of left shift, this linear feedback shift register. This is the reason this is important. And in the gate exam, many times they are asking questions from this linear feedback shift register only. We will solve some questions. Okay, but anyway, I hope this concept is clear to everyone. Okay, so okay, because like this. Okay, so very simple. So you can notice that in this linear feedback shift register, you can notice that if we initialize by 0 0 0 0, then we will go back to 0 0 0 0. So this is what we, this is not what we do. Okay, we don't initialize this linear feedback shift register using this. We don't do that. Okay, usually what we do, okay, the linear shift feedback shift register, this is usually, typically this is initialized by 1 0 0 0, means, okay, means one register. Okay, one register is set to 1 and the other registers are set to 0 0 0 0 0 and so on. Okay, and you can notice here, okay, just notice here in our example, in this example, you can notice, okay, this linear feedback shift register. So here you can notice that, okay, how many, so okay, so if you start from this state, if you start in this state 1 triple 0, if you start from this state, then after 15 clock cycles, after 15 clock pulses, you will again go get back to this state. Okay, so you can notice this state you're gonna get. Okay, so actually all these things are here. For example, 1 2, okay, again you have also, you also have 3, you also have 3, then you also have 4. Okay, I think 0 1 triple 0 also you have 0 1, yeah, so 4 also you have. Okay, so actually you can notice that, okay, okay, here you can notice that how many patterns are generated. Here you can notice 2 power n minus 1 distinct patterns are generated. Okay, in this situation you can notice if you start from this, so I can say that if you uh, wait a second. Okay, so if you start from this sequence, okay, 1 triple 0, if you start from this sequence, then from this sequence what you will get, okay, so 1 1 double 0 and so on. So actually like this 15 patterns are generated. Okay, so this is from here we started, this is our initialized condition, this is our initial state. Okay, from this state you will go to here and so on. Okay, after 15 clock pulse again you will come back to this state. So I can say that basically here 15 15 distinct patterns are generated. 15 distinct patterns we have generated. Okay, 15. Okay, so you can notice total 15 if you count 1 2 3 4. Okay, okay, 5 6 7 8 9 10 11 12 13 14 15. So total 15 distinct patterns we have generated, because we started here and after the 15 clock pulses, after 15 rising edges, after 15 positive edges of clock, we again get go back to this state. So you can notice this, finally I can say that in this linear feedback shift register, basically you can get these many distinct patterns. Okay, 2 power n minus 1, these many distinct patterns you can get. Why not 2 power n? What is the reason? So I can say that these many distinct patterns you can get. Why not 2 power n? Because I told you that if you start with triple 0, if you start with all the 0, then you will never generate any other pattern. If you start with this pattern, then you can only generate this pattern. Okay, so apart from this pattern, apart from all 0, apart from this pattern, all other patterns you can generate. So I can say that 2 power n minus 1, these many distinct patterns you can generate using this linear feedback shift register. Okay, so that is the reason this linear feedback shift register is so important. Okay, because these are the applications. So I can say the linear feedback shift register, this is generating, first of all it is generating 2 power n minus 1 distinct patterns. It is generating, also you can use this linear feedback shift register for randomness. If you want to create random numbers, if you want to create random sequence, then you can use this linear feedback shift register. Okay, so so these are the, okay, these are the registers. Each and every type of register we have already seen. First we have seen the definition of register, then we have seen type of register. Okay, what is a register? So you can notice, first we have seen register. What is the definition of register? We have seen register is nothing but n bit data storage device. Okay, so you can store, data storage device. Okay, so what is that? So I can say that register is basically using n flip-flop, because one flip-flop will store one bit. So using n flip-flop you can create n bit register. It means this n bit register will hold n bit of information it can hold. Okay, so this is n bit storage device. And I told you how the data is moving, okay, inside the register. Inside the register, whether your data is moving in a serial manner or in a parallel manner. Okay, so depending on that I can say that you have many different type of registers. Okay, so you have something called, okay, parallel in parallel out register. You have something called a shift register. Now in this shift register again we have many different type of registers we have seen. For example, serial input, okay, serial in serial out. Okay, we have also seen serial in parallel out. We have also seen parallel in serial out. Okay, so all these we have seen. We have also seen something called, okay, bidirectional. Okay, bidirectional we have seen. We have also seen universal shift register. So this universal shift register also we have seen. And also we have seen linear feedback shift register. This also we have seen. So many different type of shift register we have seen. We have also seen parallel input parallel output register. So basically all the type of registers that are there, all the type of registers we have seen. Okay, we have done the analysis, we have done the construction. So if they give you some register, let us assume, okay, let us assume some specification is given to you. Okay, they give you some, okay, so let's assume they give you some specification. If they give you some specification of register type, okay, let us assume they say that, okay, I want this type of register. Okay, so let's assume if they give you specification of register type, then you can very easily implement it. Then you can very easily implement it. Okay, so implementation they can ask. We have seen this, we have done this. Okay, for each of them we have done this. Okay, so for example, if they tell you create parallel in parallel out, then you can create it. If they tell you create parallel in serial out, you can create it. If they tell you to create universal shift register, you can create it. Okay, so all these things we have seen. Okay, after in the next lecture, okay, I am going to take all the gate exam questions, each and every gate exam question. So gate exam questions of computer science branch, electronics branch. Okay, each and every gate exam question from the registers topic I will take. Okay, so you can watch the next lecture for examples. Okay, thank you.